we have sine to an odd degree, so we're going to take out a sine and put it at the end, kind of save it for our du. So we get sine to the fourth of 2x times sine of 2x dx. So we're kind of saving this for our du, which means everything else then needs to be in terms of cosine, because we're going to set cosine as our u, and then this will be our du. So the sine to the fourth, before we can change it into cosine, we can write that as sine squared of 2x squared. And then the sine squared, once it's written like that, we can use that Pythagorean identity to put it in terms of cosine. So we get 1 minus cosine squared of 2x squared times sine of 2x dx. And this 1 minus cosine squared of 2x, we have to go ahead and square that, so we can multiply it out using FOIL. And we get 1 minus 2 cosine squared of 2x plus cosine to the fourth of 2x. And then we still have our sine of 2x dx. So now that everything's multiplied out here in the parentheses, we can go ahead and set up u substitution. We can set our u equal to cosine of 2x. That's being squared and raised to the fourth over here. And then our du is going to be the derivative of that. Derivative of cosine is negative sine. Then we have to multiply by the derivative of 2x, which is 2. So we get negative 2 sine of 2x dx. And we've got the sine of 2x dx in here. We need to multiply the inside by negative 2, outside by negative 1/2 to make everything work out here. And we end up with negative 1/2 times the antiderivative of 1 minus 2u squared plus u to the fourth du. So now it's in a form that we can actually find the antiderivative of. We've got that negative 1/2 out in front. Antiderivative of 1 du is going to be u minus antiderivative of 2u squared. We add 1 to the exponent, divide by that new exponent, so we get negative 2/3 u cubed plus, we've got u to the fifth, divided by 5 or multiplied by 1/5, plus c. So our final answer, we want that in terms of x, so we can put cosine of 2x back in for all of the u's.